Hello everyone, I'm Pu Rui, a final year undergraduate from Peking University. Today I'm presenting Virtual I2V, Renovating Road Signs for I2V Communication. This is a joint work with my advisor Chen Ren and many others. In the future vehicle-to-anything network, we envision that the vehicles will leverage the information from the infrastructure and other vehicles, which empowers them of super sensing and coordination capabilities beyond the onboard sensors. To achieve this, we first need a technology to enable data communication, which is of low cost and energy efficiency. Unfortunately, the current de facto V2X standard dedicated short-range communication fails to meet this requirement. We may as well take a step back. The legacy way for drivers to acquire information from the infrastructure is to look at the road signs. Of course, these signs are intended for human eyes and serving most static information. But they are cheap, fully passive, and everywhere. Then, our motivating question is, in order to build a machine-readable road sign capable of providing dynamic information, and in order to find cheap and gradually deployable I2V technology, can we bridge this gap between new smart infrastructure and conventional road signs? I am trying to answer a big yes with the visible light backscatter, which works as follows. Nowadays, most road signs use a special surface material called reflector, which will redirect the beam back to the source with high directionality. This enhances its visibility at night to the illuminating vehicle. And this phenomenon becomes a visible light backscatter simply by adding a modulation and demodulation overlay circuitry. That is, a liquid crystal shutter to control the reflection, and a co-located light sensor that will detect the reflection intensity change to decode the information. First, this technology is compatible with road signs and highlights, so we achieve the first goal of a better road sign. Secondly, like any other backscatter communication technology, the visible light backscatter relies on only harvested energy and can run independently without any external power source to provide I2V connectivity much cheaper than DSRC. However, there are still two challenges ahead of us. The first challenge is how to achieve long communication distance. This is critical for road safety because it allows to discover the emergency early and to leave enough time for action. But current visible light solutions only target indoor applications and have very short communication range. To achieve a long range, the key issue is higher signal to interference plus noise ratio. Therefore, we need to lower the negative impact caused by ambient light interference, self-interference, and random noise. Our high-level solution is first to adopt a switching carrier that filters DC light interference. Then we design a polarization differential reception scheme exploiting polarization modulating nature of liquid crystal. Such a scheme not only cancels unpolarized reflection interference, but also provides 6 dB gain of signal over the shoot noise. The second challenge is to handle coexisting readers and tags, which requires a many-to-many MAC protocol. To design a many-to-many MAC protocol, we propose two simple yet effective methods. First, we let the readers to wait for a random period before sending when no uplink energy is detected to avoid downlink collision. Second, we do not allow readers to send when uplink data is detected to avoid be interfered by ongoing traffic. also known as asynchronous uplink collision. Finally, I will show some key results over three main aspects. First, for the physics layer, our prototype can communicate from 60 to 80 meters away with 1 kilobits per second data rate. Also, our system is reliable under a high mobility. For the MAC layer, we tested under an extreme many-to-many scenario and find that adding number of readers only marginally affect the performance. The third is cost and power consumption. RetroSign achieves 10 times lower deployment cost and 100 times lower power consumption compared to DSRC. With this, I would like to conclude my talk and thanks for your attention.